Hi everyone, welcome back to our new video of the series where we are discussing time complexity. We have already defined what is time complexity. We have already seen the formula for time complexity, and also we have gone through the various way of representing, or I say calculating, time complexity, that is best, worst and the average cases. In this video, let's take an example for calculating time complexity. So how do we calculate time complexity? Let's take the example. Before starting the example series, let's have an assumption that, because if you remember, the formula of time complexity was C of operation into C of x. This was the function and this was the time taken for one basic operation execution, right? So this was constant, we were totally dependent on C of x, right? So to in the same way we have done in space complexity also, that we have taken the fixed space, right, the dependent space as an constant space, because you should not calculate 4 bytes 4 bytes 4 bytes again. I just say that it is one unit of constant space. In a similar way, i assume that I assume that basic operation takes 1 unit of time, right? 1 unit of time. Now it depends, it can take 5 seconds, 10 seconds, whatever the time, right? I'm not calculating that. I take, it's a 1 unit of constant space, constant time here. Okay, so let's start with an example. For example, you have a and b, and then you store a plus b value in the sum. So how many times this basic operation will be executed? It will be once, right? Because you have a, you have b, whatever the values of a and b. Once a plus b, you got your result in sum, right? So only one time this basic operation will be calculated. So we write time complexity as O of 1. In the similar way, if you calculate difference also, you have a or b, so only one time you calculate a minus b. This, you do this computation once and you store that value in difference, you get your output of the algorithm, right? So again, one time execution. So I write the algorithm of difference is also, I have written the basic steps here, okay? I have not written the complete algorithm. Okay, so you understand that there is a, b, and then a plus b. The algorithm talks about sum, here difference, and there is a general incremental. Okay, I am just incrementing a count. So I do something, I don't know what I have done is, but at the end I'm just doing count plus 1. Though it depends what you are doing, I'm just simply defining count as 0. Okay, count and 0, and I'm just increasing that count. That's it. So here count will become as 1. That's it. That's only I'm doing, right? Because it depends where this increment is happening. Is it happening in for loop, in how many for loop, in recursive function? So all those things will also matters. We'll see some more complex examples in our coming videos, but to understand the basic operation execution field, I just started with a very basic example that O of 1 means a 1 unit constant time, right? So we'll define that way. So here also it's executed once, so I'll write O of 1. I hope you are clear with calculating time complexity. That is, you need to understand how many times the basic operation of an algorithm is being executed. Also remember the point here that sometimes you may get confused in understanding which is the basic operation, right? So you have to carefully understand. Sometimes there can be two basic operations. I am totally agree with, right? You may understand that in one of the loop this one thing is happening, in another of the loop the other thing is happening. Though we'll take the examples of such problem also, but I'm just defining it. So don't get confused that there will be one basic operation in complete algorithm. There can be many basic operations in the algorithm. Also the case can be that you are thinking some operation as a basic operation, but it's not that, right? Don't worry that I'm speaking that much. We'll take all these scenarios in our coming examples. So if you like the videos, please do like, share and subscribe. Thank you.